What up, guys? In this video, we'll be showing you how to solve a first order linear differential equation with an initial value. So this is the linear differential equation that's given to us. I'm going to say LDE for now, just for short. And this is the initial value that they've given to us. So how do we solve this? First of all, we need to figure out if this is in the form of a first order LDE. Well, this is dy over dx, and it is by itself. This is p of x, and finally this is q of x. So this means that it is the first order linear differential equation. Second, we need to find the integration factor. Okay, so let's find the integration factor. It will be e to the power of tan x dx. And the integration for e to the power, the integration of tan x is negative ln cos of x, or this could be written as ln secant of x. Okay, secant of x. Okay, so this is our integration factor. Okay, don't worry, you're not wrong. We're not wrong. This should be it. Okay. So now we have to multiply this across this whole thing. So this becomes e to the power ln, secant x y prime plus tan x y ln secant x equals e to the power ln secant x cos squared x. Okay, so remember how I said that there's this little trick right here that we use right here, right? This saves you a lot of time. Okay, so to save the amount of time, we just use that instead of taking the integration of all this in terms of taking the integration of this in terms of x. That's too much. So let us save some time and use this equation. So our integration factor is e to the power ln secant of x. Oops. So what I just noticed, e to the power ln secant of x. Remember what we said in another video, with exponential expression, logarithmic expressions, e to the power ln of anything is the argument itself. So e to the power ln secant of x is actually secant of x itself. So yeah, so that's, oops, kind of forgot about that. Forgot to put that in. Okay, so this is the same thing. E to the power ln secant of x is the same thing as secant of x. How? Just look at my previous video and you'll see there is well, actually, e to the power ln 20 is 20. Okay, e to the power ln 10 is 10. Okay, so these are some little exponential expression laws. Okay, so e to the power ln secant of x, I don't even need to write that again. Trying to make my thing a lot easier. So what we could do is use this equation. Our integrating factor is secant of x. Cool. Times y equals the integration of cos squared x times our integrating factor, which is secant of x. Okay, nice. And this is dx. Okay, so we could leave this by itself. So secant x y is equal to, now cos squared x secant of x is saying cos squared x over cos x. How do I know that? Just trig laws. Secant of x, right? Secant of x is equal to 1 over cos of x, right? So I just put that in. Okay, cool. So now we still have to take the integration of this. Some constant. Remember to always put this constant. Okay, I emphasize because a lot of people forget. Okay, so now we're almost done. We just need to put the y by itself, and then we'll be using the initial value that they've given to us. It is sine x times cos of x plus c times cos of x. Okay, cool. Now all we do, we have something in common. Let's just, okay, well, if you want to simplify it even more, y equals sine x. Actually, so these are in common, right? So cos x sine x plus c. Okay, now since this is a lot more simpler, we can start using the initial value, which was given to us, as we recall that the initial value was y of 0 equals 2. Okay, cool. So just to plug in our initial value, we're going to just plug in our initial value. So y at 0 is equal to 2. So when x is equal to 0, y is equal to 2. So y is equal to 2. X equals 0, so cos of 0 is 1. Sine of 0 is 0 plus the constant c. So our c, well, 2 is equal to c. So our c is equal to 2. There you go. Our final answer is y equals cos of x times sine x plus 2. To make it a little bit more clear for you, these are the arguments. Okay? So there you have it. This is your final answer to the initial value problem.